Code transcription. We are at chapter 6 now, and what you're going to do today is
lowering to LLVM and code generation. Here we'll target LLVM IR for code generation and detail more of the lowering framework.
So this includes the lowering to LLVM. And we need the type conversion. Also, we'll do full lowering, which means our print will be converted to LLVM MLIR like this. So how we run the print is we have a multi-dimension constant here, and the constant is 2x3 tensor, and we will loop. Oh, okay, it's transposed to 3x2, and then we're gonna loop for the outer dimension and then inner dimension, and then print each of the elements by using printf of LLVM built-in internal function like this. So we are generating assembly code. Sorry, this is LLVM IR, and it's going to be generated into machine code, and also we can run JIT, just-in-time compilation. Today I'm so thrilled because today's episode is actually making this compiler work in a real machine. So the language looks like it is this is the main function. We have two tensors. We will call user-defined function called multiply transpose. It just transposes each matrix and does element-wise multiplication. So all these codes are going to be converted into machine code, machine level code that can run on CPU. Okay, let's get started. So like I did it before, I made a diff from chapter 5 to chapter 6. In other words, we have a source code for chapter 5 and we have a source code for chapter 6. In the last episode, we finished compiling chapter 5 source code after transcribing each of the functions. And now we have a difference between these two chapters. That's ready here. So as we did, we will do as we will transcribe in top-down fashion. So from here, this is top toyc.cpp, which has the main function. We'll go down to machine code generation from this top level function. So before doing that, let's just start with the changing makefile. Let's apply the diff by ourselves. So because we're depending on JIT, we need a simple check here. So we're checking if not. Execution engine. link components, we have two more link components. One is a core, native code gen, or RCG. I'm not going to change this one. It's just simply changing chapter 5 to chapter 6. Here we have one more C++ file called lower to LLVM.cpp. And the dependency didn't change at all, but only the chapter number changed, so I'm not going to change this. And then we have a conversion libraries added to the target link libraries. So we will get the property first. The property conversion lips global. Conversion lips. Then definitely we have to include the conversion lips here, and also we have several more libraries, MLIR execution engine for just-in-time compilation, and LLVM command. Looks like we have additional dialects we're using. Target LLVM IR export. Okay, we are done with this file. Let's move on to the next file. I think we have one more CMake file. Let's finish it. Okay, these are just for changing the target name by replacing chapter 5 with chapter 6. I'm going to skip it. Path 6 looks like very simple. I'm going to type it right now. Create a lower to LLVM path. Looks like this one is for the factory function for creating paths for lowering to LLVM.
Create a pass for lowering operations the remaining two operations, as well as affine and std, to the LLVM dialect for codegen.
Okay. ops.td looks like it's pretty simple. Let's just type it in. Type the code in. I think the code is just simply changing the code location. Assembly format, input, type input, attribute dictionary to type results. Okay, it's the same. Enable registering canonicalization pattern with this operation. Let has a canonicalizer. I think the code, just the code location is changed. The results definition should come after there has canon equalizer definition for the ops.td. Right above return up this one. Okay. Now how about moving on to toy.cpp, and then we'll have to write the new file lower to LLVM. Transcribing this is going to be a headache, so just keep it there. Let's try to focus on typing the code in toy.cpp. Okay, let's open up the toy.cpp. Let me actually open it in Visual Studio Code. Toy.cpp. Oh, no, I can't because it's viewing div. I have to select this. Translation. H. We have three more enumeration elements here. source manager is removed, but it's added as a local variable. Context, we have a context here. Oh, dump MLIR. Load and process MLIR. First, the context parameter is changed call by reference to call by reference, and module owning ref module, owning up ref module up module. Context and module are passed as a parameter, and the function name changed. For loading MLIR, because we removed the source manager, we are not passing source manager anymore. So we have to declare source manager here. And also we created source manager handler. Context get or load dialect is removed, right? I'm wondering if we can simply remove it. I guess there should be, oh, here, it's moved to here. We're going to load our dialect here. I guess it's better to type the main function first. And looks like we have to remove the switch statement here and replace it with the if else. Sorry, just if multiple if statements. And then finally we return error, because in each if statement we are returning if some task is successful or not.
If we aren't dumping the AST, then we are compiling with stroke to MLIR.
Okay. This is for just-in-time compilation. Looks like it's just 15 or 20 lines of code. Very cool. Dump LLVM IR is added as well. And this is the code we were going to change. Context and module into parameter first. Dump MLIR. Load and process MLIR. Load and we have a context here as a call by reference parameter, and also module as a call by reference parameter because we're going to reuse it. And this is not necessary anymore because we are loading our dialect in the main function as we have seen now. And then we are calling load MLIR. But without the first parameter, without the source MGR. And these two lines are gone. Well, we needed this. What's this?
Don't we need the diagnostic handler? This class is a utility diagnostic handler for use with LLVM, source MGR. Load and process MLIR. This one we have to remove it, and we only have a load MLIR. Okay. Path manager is lowering to a fine, and also we have a more flag called is lowering to LLVM. If this is turned on, dump is removed. We have two new functions. One is dump LLVM IR and another is run JIT. From this file, I will type in using Visual Studio Code. Dump LLVM IR and run JIT.
Register the translation to LLVM IR with the MLIR context. Convert the module to LLVM IR in a new LLVM IR context.
Initialize LLVM task.
Optionally run an optimization pipeline over the LLVM module.
Translation to LLVM IR. Register LLVM dialect translation. this is printing the LLVM IR. I'm not sure why it's printed into errors. I guess this is just LLVM IR. Did we do the same thing? Dump. Runs it.
Initialize LLVM 타작스.
Register the translation from MLIR to LLVM IR, which must happen before we can JIT compile. An optimization pipeline to use within the execution engine. Create an MLIR execution engine. The execution engine legally JIT compiles the module.
OPT pipeline. Maybe engine.
Invoke the JIT compiled function.
We're calling the main function. Okay. Now the last file we have to type in is lower to LLVM.
may wonder why I'm typing these include directives, because I want to be familiar with these header files. Conversion to standard. Conversion arith to LLVM. Control flow to LLVM. These are all header files having patterns for converting one dialect to another dialect. For example, arithmetic dialect to LLVM dialect. Conversion font to LLVM. Conversion font to LLVM. Conversion convert font to LLVM plus.
Toitom rebrite patterns.
Like you did, we will just write
classes and function signatures only at this point, because we want to do it. We want to transcribe for each function in top-down fashion. Get operation name. Let's skip it for now. We have two private functions.
Return a symbol reference to the print function, inserting it into the module if necessary.
토이탈 글로어링 커스.
create a pass for lowering operations the remaining toy operations, as well as affine and STD, to the LLVM dialect for cogen.
Okay, this is the main builder function which returns the toy to LLVM lowering pass, and it's going to be used in the toy.cpp. Let's just see where it is. Here is lowering to LLVM, then we are adding pass. After creating the lower to LLVM pass. So how we define this is here. We're defining the dependent dialects. It means our dialect is going to be converted into LLVM dialect and also SCF dialect. SCF dialect is required for lowering the loop nest. SCF means structured control flow. This is by Copilot. And for each operation, we are running run operation. Let's just see what it is.
The first thing to define is the conversion target. This will define the final target for this lowering. For this lowering, we are only targeting the LLVM dialect.
Okay. Is illegal.
During this lowering, we will also be lowering the memref types that are currently being operated on to a representation in LLVM. To perform this conversion, we use a type converter as part of the lowering. This converter details how one type maps to another. This is necessary now that we will be doing more complicated lowerings involving loop region arguments. Now that the conversion target has been defined, we need to provide the patterns used for lowering. At this point of the compilation process, we have a combination of toy, affine, and STD operations. Luckily, there already exists a set of patterns to transform affine and STD dialects. These patterns lowering in multiple stages, relying on transitive lowerings. Transitive lowering, or A, B, C lowering, is when multiple patterns must be applied to fully transform an illegal operation into a set of legal ones.
Okay. So from SCCF, it's converted to control flow, and control flow converted to LLVM. We're going to define this print up lowering, so we can see that patterns are having classes like this, and these are all adding patterns related to converting one dialect to another dialect. We want to
completely lower to LLVM, so we use a full conversion. This ensures that only legal operations will remain after the conversion.
So what we have not transcribed is this class. Let's type in this class right now. Actually, I feel a little bit tired, so I guess it's much better to come back maybe this evening. What's left is print up lowering. Okay, I'll come back soon. Thank you.